My name is Fabio Garcea, and I'm a PhD student in Polytechnic of Turin. I am part of GRAINS, a research group of the university that studies computer vision and human-machine interaction. Nowadays, many different computer vision tasks are often solved using neural networks and artificial intelligence. These technologies are becoming widely used, and even if we may not think about it, we can find them even in the applications of the phone that we are carrying in our jeans. Consider, as an example scenario, the trip you make every day to drive your car to the office. On the road, you can recognize very different and potentially dangerous scenes, like a distracted person walking on a pedestrian crossing, or unexpected roadworks that require you to change your usual trip. We are, as humans, capable of recognizing all these situations thanks to the knowledge acquired through years of experience. So how can these tasks be tackled by an AI? With a strategy that is similar to the one used by humans, neural networks learn during the training phase to solve a particular task. This can be achieved showing to the network many labeled examples of these situations and forcing it to optimize its own predictions. In other words, by making the network having experience. As another example, we can easily train a network to classify images of dogs and cats by training it on a large number of images of these two animals. However, as you can imagine, there is a wide set of applications in the field of computer vision in which this technology can be used. However, many of these applications have inherent potential risks that must be considered. The previous scenario, on the recognition of different situations during a road trip, and more in general, the topic of the autonomous driven vehicle is a perfect example of an application that brings with it inherent safety risks. In the medical field, neural networks are often used to produce image-based disease diagnosis to help the physicians in their work. This again is a scenario that brings in a great safety risk due to the presence of humans involved in the classification tasks. These are just few examples that put under the spotlight the need for deep learning researchers and practitioners to understand and consequently trust the decision-making process applied by these technologies before deploying them under scenarios in which safety is crucial. Unfortunately, deep learning models are black box models, as their fully subsymbolic internal knowledge representation makes it impossible for human developers and users to understand the rationale behind the model decision process. Effective visualization techniques can facilitate the comprehension of machine learning models by practitioners and end users alike. Several visualization techniques have been crucial to develop an intuitive understanding of how convolutional neural networks interpret images. As an example, a complete family of explainable AI techniques produce this explanation of a model classification in the form of a heat map, by highlighting with different intensity portions of the image that push the model to give a certain prediction. In our previous example on the classification of dogs and cats, we should expect to see as explanations highlighted portions of the image for those parts that were crucial for the model to understand what animal it was classifying. The same would apply for images of roadworks or diseases. My research objective is to study effective and intuitive visualization of data models and machine learning applications by developing new general-purpose and application-specific tools in order to allow users to derive insights from the model, as well as supply new information to the systems, thus supporting training techniques as online and adaptive learning. The benefit of this research is an enhanced and deeper understanding of the inner decision process of neural networks. Thus, promoting a more aware interaction with the models during the learning phase, and providing end users with richer explanations and consequently making the system more trustable.